We're in section 10.2 where we are going to look at polygons and more specifically quadrilaterals. So if you look at the notes here, we have the definition of a polygon. It says it's a closed plane figures whose sides are segments, line segments, that intersect only at their endpoints. Okay, so uh, what we can say here is we have several different figures shown here. And the one thing that we have to keep in mind is, do we have any line segments? And I can say yes to this figure here. Every single endpoint is a line segment and it connects to their endpoints. This one here is also all line segments, all line segments, all line segments. The only one that doesn't have a line segment is this one. And the reason for that is we have this curvature right here that is not a line segment. So of the 1, 2, 3, 4, 5 figures, 4 of them are polygons. Okay, so things that do not make a polygon are kind of shown here. So if you have any type of intersection, so in this case, yeah, it does have all line segments, but they intersect. So there's the intersection right here. So that can happen. If you see any curvatures, so like this one was a curvature, can't have that. So curvatures like that one. And if you have any non-closed sections, so like say we have this open section right here, because of this open section, it is not considered a polygon. All right. Once we start going to uh, what are in fact polygons, we have more specific names that we can attach to these polygons. One of the more specific types of polygons that we are going to kind of look at and investigate are regular polygons. Regular polygons, um, all the sides are the same and all of the interior angle measures are the same. So if you look at this triangle, we have all the same side lengths, and each one of these angle measures are the same. All right, that goes with this shape here and this shape here. Okay, same rules apply. All the sides are the same, and all the angle measures are the same. So anytime you are given directions like we have a regular polygon with so many sides, we can say, all right, because it's regular, because the statement says it's regular, we can make the assumption that all of the sides are the same and all the angle measures are the same, and that's going to help us being able to solve whatever problem that they ask us to find. There are also different types of polygons that are classified as either convex polygons or concave polygons. So convex polygons, basically I could say this. It says a polygon is convex if a segment jointing any two interior points lies completely within the polygon. So here is what I would like you guys to do in order to determine if a uh, a polygon is um, convex or concave. So if you have like a straight edge here, let's see if I can, all right, so I can rotate it like this. So what you're gonna do is you're gonna take your straight edge and you're gonna kind of line it up with each endpoint. So I can't do it that greatly. So if I go here, okay. So first off, I look at this, I line up my straight edge, and no part of my straight edge lies inside that particular polygon. So And what I have to do is I have to check it with every single side in order to prove this point. Okay, because if it just happens to be one side doesn't work, it's considered convex. So here, and then let's see if I can get this one to go here. And then finally the last one goes here. So I was able to go the entire revolution of this polygon. And my straight edge, when I was touching one of the side lengths, it did not intersect in the interior. When you can say that all of them satisfies those qualifications, we can say that they are convex. Now, concave, all it has to do is you have to find one. So, yeah, there may be some instances where it doesn't work, where it would be okay. So, like, for instance, right here, it doesn't touch. But if I go to this side over here, I get the intersection right here. And because of that intersection and just that one line segment, I can say that that polygon is concave. So if we were to kind of go back to the first page here and say, all right, of the four that are in fact polygons, are they concave or convex? Well, I can say that this first one here is concave. The reason for that is if I were to put a straight edge here, I would see that the intersection would be located there. If I look at this one here, 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 and here, it doesn't intersect. This is convex. Again, here, 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 no intersection, convex. And I see that if I went like this, ooh, I got the intersection in the interior. This one is concave. Okay. So that is how you can kind of determine whether they're convex or concave polynomials. If we have a quadrilateral, quadrilaterals are any four-sided polygon. We have also more specific names that we attach to those polygons. So the first one that we have here is a trapezoid. A trapezoid has exactly one pair of parallel sides. So that means that the other two sides are not parallel. So these two line segments are parallel, and it's denoted by those little arrow marks there. Um, a parallelogram has both uh, pairs of opposite sides that are parallel. So I have these two sides are parallel, these two sides are parallel. That's how we go about solving that. A rhombus has the same characteristics as a parallelogram. The only difference is all four sides are equal in measure. A rectangle is got the same characteristics as a parallelogram, except each interior angle is at 90 degrees, and square has the same characteristics as parallelogram and as a rectangle, but and as a rhombus, because not only is both sides parallel, not only are all four angles 90 degrees, but all four sides are equal. All right, so in these particular questions are asking you to classify the quadrilateral. Now, when you are asked to classify quadrilateral, you are only able to use the information that is given to you. Okay, so don't assume anything unless it's actually drawn. So, for instance, you could have a shape that looks like this, and you could say, all right, there's nothing, there's no other measurements, there's nothing stating that they are parallel, there's nothing stated that the angles are right angles or whatever. So just from this perspective with no other information, all we can say is this is a quadrilateral. Now, if they had some other um, measurements, if they had 90-degree angles, stuff like that, we can make a more accurate assessment. But because that was all they gave us, this is what we can say. So for number 7, they have they have the parallel signs here and here and here and here. So we have two sets of parallel lines. So we know it's at least a parallelogram. The sides, opposite, all the four sides are not equal, so we know it's not a rhombus. Well, we do know that we have four 90-degree angles, so we could say that this is a rectangle. For number 8, we have two sets of parallel lines, so we know it's at least a parallelogram. We don't have any measurements of sides, so we can't make any assumptions of it being a rhombus, so we can say that the most specific uh, quadrilateral is a parallelogram. And then for this one, since there's no measurements, all we know we have 1, 2, 3, 4 sides. All we can assume is that this is a quadrilateral. You know, is it a trapezoid? I don't know. There's no one set of parallel lines, so we can't make that assumption. So here's a little chart. It says finding the sum of angle measures. So quadrilateral, all right, so we got 4 sides here. Pentagon's got 5. Hexagon's got 6. Heptagon's got 7. Octagon's got 8. All right. So this is going to kind of help us out figuring out the sum of the angle measures, the sum of the interior angle measures. So what they want to do here is they are asking us to, it says triangles formed. So if you pick one vertice, so like if I pick one vertice here, one vertice here, 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 and here, and I'm going to create line segments on the inside of the of the polygon. So I can make an intersection here, I can make an intersection here, here, I can make an intersection here, here, and here, 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 and here, and then finally here, 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 and there. So what we need to look at is how many triangles did we form? I formed 1, 2 for the quadrilateral. I formed 1, 2, 3 for the pentagon. 1, 2, 3, 4 for the hexagon. 1, 2, 3, 4, 5 for the heptagon, and 1, 2, 3, 4, 5, 6 for the octagon. So now, how is that going to help us? So to figure out the sum of the angle measures, we simply take how many triangles it formed, which in this case is 2 for the quadrilateral, and then what we take the information that we learned from yesterday is that all interior angles of a triangle have to be a sum of 180 degrees, so we simply multiply it by 180. So 2 times 180 gives me 360. So what that's telling us is that doesn't matter what kind of um, quadrilateral we have, whether it's a trapezoid, parallelogram, rhombus, rectangle, or square, we know that the sum of all of the interior angles is going to add up to 360 degrees. All right, so same thing for the pentagon. I got 2, or not 2, we got 3 times it by 180. So 3 times it by 180 gives us 540 degrees. And I got 4 times 180. 4 times 180 is 720 degrees. I got 5 times 180, which is 900 degrees. And then finally 6 times 180 is 1080 degrees. Okay, so you can reference that for different different side measures to give us an idea of what the sum is for the interior angles of a certain sided polygon. Okay, more, and it's got to be convex. All right, can't be concave. So we kind of made this this chart here. So, but like what a lot of people ask is, well, what if they're larger than an octagon? So let's just say we had like a 12-sided figure. We can take the correlation with that. So let's look at this. So we had 4 sides, we had 2 triangles, 5 and 3, 6, 4, 7, 5, 8, 6. It looks like you can form 2 less triangles by the number of sides it has. So I bet you we could form 10 triangles with a 12-sided figure. So to figure out a 12-sided figure, we just take 10 and times it by 180, which then will give you 1800 degrees. Okay, so that's how you can figure that out from there. Also, you have a formula of any convex n-gon, and you could say just n minus 2. All right. So here it says we have a regular polygon. So the measures of the interior angles of a regular polygon are all the same. So what we can do here, it says how can we find the measurement of the interior angles of a regular polygon, and the formula is right here. So if whatever side figure it is, we can say if n was 5, like this one, 1, 2, 3, 4, 5, we can figure out the angle by replacing n with 5 and then solving. Okay. So I go here, it says find the sum of the measures of an interior angle of a regular polygon with the given side measurements. So it's asking for the sum of the measures. So all we're going to do is, okay, so we have an 8-sided figure, which we use the chart, and we know that it creates 6 triangles. So we just take 6 triangles times by 180, 6 times 180. We said it was 8. It was 1080 degrees. So that would be the sum of a 8-sided figure. We have a 14-sided figure. We can create 12 triangles, multiply that by 180, and we can have 2160 degrees as the sum. All right, then finally it says find the measure of the interior angles of each of the polygons above. So all we have to do is we divide these values here by n. So if we have an 8-sided figure, we divide this by 8. So 1080 divided by 8 is 135 degrees. We have a 14-sided figure, so we divide that by 14. 2160 divided by 14 gives us about 154 point, we'll say 29 degrees. All right, I kind of rounded. All right, so that's what we're looking for there. And that is being able to investigate polygons and more specifically quadrilaterals. Hope this helps. Until next time.